If you observe very here, so last class we discussed so many things like what is the relationship between time period and as well as angular acceleration or angular velocity. So what is the symbol of angular velocity? We have studied in last class. What is the symbol of angular velocity? All of you? This is
Omega.
called as something.
Omega.
Omega. Yes. So if you notice it, we studied the relationship between acceleration and as well as angular velocity and as well as frequency. What is the relationship between angular velocity and frequency? Omega is equals to 2 pi f. And same way we studied omega and time period. What is the relation, everybody? 2 pi into, so frequency means we all knows that. What is the frequency? 1 by time period. Yes or no? So omega is equals to 2 pi f. I think till here I taught 2 pi t. So till here I taught and I have given you that. So what we are going to study in our today's class. Am I right, everybody? So
Yes, sir.
let us see that we already know, we have derived that displacement is equals to radius into, that is what angular displacement and linear displacement. This is linear and this is angular. So the linear displacement is equals to radius into angular displacement. Same way linear velocity is equals to radius into angular velocity. Same way now today's class I am going to introduce a new thing. Linear acceleration is equals to radius into alpha. Alpha means, all of you remember what is alpha in the sense of angular acceleration. See, this all linear acceleration, linear, and this is angular. So let us see that what is the types of acceleration and everything. So we are having mainly three types of accelerations. One is centripetal acceleration, next one is tangential, next one is angular acceleration. So we'll discuss it one by one. So all of you remember centripetal acceleration, we people represent with the AC. A subscript is C is called as centripetal acceleration. Tangential acceleration is always will represent with the A and small t. This is called as tangential acceleration. And angular acceleration already I mentioned. What is the angular acceleration symbol, everybody? Yes, please.
Alpha.
Alpha. So that is what you have to remember it. Understand, everybody? So a next type of acceleration which we are going to study, of course, angular acceleration is the last one. If this two, if I make it, then that is what we used to call as third one. So third type of acceleration, which is called as net acceleration. So which will represent with the A NET, subscript NET. What do you mean by A NET? Net acceleration. Clear, Amma? Aswita? So that is the types of acceleration. Totally, we are having 4 types of accelerations. One is centripetal acceleration. Second one is what? All of you. Tangential acceleration. Third one is net acceleration. Fourth one is angular acceleration. Okay. So let us discuss one by one and we'll solve plenty of numericals also. So first, all of you keep ready. Centripetal acceleration. What is that? All of you? Centripetal acceleration. Okay, everyone. So now let us go back just 2 minutes for class 9th and we'll revise. So we all know that when the object is in circular motion, class 9th, you remember and tell me. So speed is equals to circumference of a circle 2 pi r divided by time taken. Am I right or wrong, Pradosh? Yes or no?
Sir.
Yes. All of you, others. And that is what? So this is not a speed actually, it is a velocity even. So we all, if you notice it, maybe body can travel in the constant speed, but is it possible to travel in the constant velocity, everybody, in circular path?
No, sir.
No. Why? In a circular path, at every point,
Direction vary.
what is changing? At every point, direction changes. So that in circular path, all of you remember, maybe the speed of the body remains constant, but who is not at all constant? Everybody. The velocity will never be constant. Even though the magnitude of velocity, what is the magnitude of velocity? We used to call something. What is that called as? Magnitude of velocity only we used to call something. Yes, Rudreshwar. Mod of V we used to call something. What is that called as?
Speed.
Speed.
Understanding? Magnitude of velocity only called as speed. Yes or no?
Yes.
So many things we solved because speed is a scalar quantity and velocity is a what quantity? Vector quantity. So, okay. So vector quantity, velocity changes not only by changing the magnitude, also by changing the what? Also by changing the direction. I taught you or not? This chapter only we studied. Am I right, everyone?
Yes.
Yes. So velocity will never be constant in a circular track, but speed of the body may remains constant. But sometimes maybe speed also can change as increases, decreases, increases, decreases. Yes, Mr. Udesha? Yes or no? Yes, there is a possibility. So, okay. So now let us take centripetal acceleration means I will take it everybody. So speed of the body remains may constant, but who is not constant? At every point, who is not constant, guys? Velocity is not constant. Understanding? So if you teach that class 9th gravitation chapter, you might be remember that one boy is tying the stone through the thread and is squirreling around it. Am I right or wrong? Everybody, do you remember that activity? Class 9th, one boy is standing in the middle and he is tying some rope and he will be keep on rotating in a particular path. Do you remember this, everybody?
Yes, sir.
Yes. So always you can see, for example, he stop applying the force at this point. So at this point, body will travel in a straight line. Suppose when the body is here, he stop apply the force. Then from that point, it will start in a linear point. Is it right or wrong? Everybody? Yes.
Sir.
If we stop apply the force at this point, then from that point, the body will go in a straight line. So that is why somebody is always trying to make the body to rotate in a particular path. That force only we used to call by the time class 9th. What is the force we used to call as? We used to call as centripetal force. And always remember, centripetal force always act at any point. Centripetal force always act towards the what? Always act towards the center. Understanding, Amma? Clear? So that is only here also. So observe very carefully the same concept here, but we'll write a acceleration formula also here. Class 9th, no, you never find an acceleration formula for circular motion. Am I right, everybody? Only we have a speed or velocity formula. Am I correct? Yes, please. Not even velocity. We have only one thing. What is the formula in circular motion? Everybody, we're having a speed formula alone in class 9th. Yes or no? All of you. Now, as we know that velocity always varies. Velocity varies a constant. Everybody, velocity variable. So how we can variable the velocity? Even though the magnitude of velocity, speed of the body is constant, but what can changes at every point? Yes, please. Change in every point. What can change, guys? Change in direction. So that if the change in direction means body is said to be in acceleration or not to be in acceleration motion. Everybody.
Actually.
It is said to be in acceleration. That is what you have to remember. So to give change in direction of velocity, always you remember the body in circular motion is always having the centripetal acceleration. Means at any point, for example, if I take at this point, let me notice the 4 points in this. So at this point, the velocity of the body is acting in what direction? Everybody. It is acting perpendicularly to the center. Yes or no? So at this point, let me mark at this point and let me mark at this point. So I will take now 4 things. All of you have to notice it very carefully. So at this point, it will be acting like this. Now at this point, it will be acting like it will be acting towards to my left. Am I right or wrong, everybody? Yes. Pradosh, understood? And at this point, it is acting like this direction. And if you notice it, at this point, it is acting maybe upward or downward. So it is acting upward direction. So this is what at every point, velocities remains constant or keep on changes. Everybody, velocities keep on changing. Why? The velocity is not changing, but what is changing, everybody? Yes, please. What is changing? Direction is changing. Understand, Ra? Nobody will say. Okay. So the magnitude of the body remains constant. Maybe the body can travel with the same constant acceleration, constant speed. But what is keep on changing? Everybody. Yes, please. Direction is changing. As it is, direction is changing. The body's acceleration is also always the body is said to be in what, guys? Accelerated motion or not? Yes.
Accelerated.
Yeah. So at every point, if you have taken, I will take the 4 points. So at this point also, the force, the acceleration is acting towards the what? At this point also, it is acting towards the what,
Center.
guys? Towards the so at every point, you can notice it, the acceleration of the body is acting always towards to the center. So the force or acceleration, the acceleration which is acting always towards to the center, you can see that is only which to called as what acceleration, which makes the body to revolve in a particular path. Everything which to called as what
Centripetal
acceleration is to say? Centripetal acceleration. That is what you have to remember. Is it okay, everybody? Yes, please.
Yes, sir.
Yeah.
Yes, sir.
So because velocity is not constant, so who is remains constant? Who is remains constant?
Heat.
Speed of the body. That is why I'm removing this arrow. All of you observe. So at every point, magnitude of the velocities remains may constant, but to give the change in direction of velocity, make the bodies always in accelerated motion. Am I right, everybody? Clear? And you tell me this centripetal acceleration is always acting on the where? We all know that from the center to the any point, we used to call something. What we used to call? It is which is also
Radius.
constant.
Radius.
Understand?
Radius.
So that is only the centripetal acceleration formula. Please learn it. Centripetal acceleration formula v square by r. And remember, v means what? Speed or velocity? V means
Speed.
and r means what? R means
Radius.
okay. And keep it in mind, centripetal acceleration act along the what? Centripetal acceleration act along the radius, or it will always act towards the what, guys? It will
Center.
always act towards the center. Understand, Aswita? Clear? Now, so we all knows
Yes,
that
sir.
angular velocity formula, velocity and angular velocity formula, up only we have written v is equals to what? Substitute it here. V is equals to what? We all knows that. Linear
R into omega.
Yes, please.
R
So we
into
all knows that.
R into omega.
We know that angular velocity or speed, which is equals to what is the formula? Radius into omega. Am I right?
Omega.
So omega means what? What do you mean by omega?
Angular velocity.
Angular velocity.
Velocity.
Substitute in this formula and you tell me what you'll get. So V means R into omega whole square divided by R. So it will turns into, you should speak, I am not. So which is equals to R square into omega square divided by R. R will get cancelled. What is the centripetal acceleration formula, everyone?
R omega.
Centripetal acceleration formula R omega square. The first formula you are learning in circular motion. So please make it quick. In acceleration. So the first acceleration. What is the acceleration, everybody here? Centripetal acceleration. So keep it in mind, centripetal acceleration, what is remains constant? Magnitude of velocity is constant, but still velocity is not constant velocity, variable velocity. Why it is variable velocity, everyone? Who is changing?
Change in direction.
Direction is changing.
Change in direction. Understand? Princey, Sai Karthik, Mr. Rishi, that is what you have to remember it. Okay, guys? Clear? Yes, please make it.
Yeah.
Laksha called Ishali, I think she thought it night class. Completed, everybody? Understand, Ra? Please respond. So, now also I am saying you the one point and another thing also. Centripetal acceleration will never be zero when the object is in circular motion. Is it okay, guys? Everybody? So, note that point. And always centripetal acceleration acting along the where? Aswita, acting along the where? Acting
Radius
along
towards
the
the
radius, or it is acting towards the
Center.
that is only ways to called as centripetal acceleration. Anybody having any problem? You can ask. Clear, guys? Yes?
Yes, sir.
Yeah, please proceed.
Yes, sir.
Next. Tangential acceleration. Mr. Murali, can you able to understand? Mr. Rishi? Call to that Monish also. Somebody call to that Monish. Yeah, can you able to understand, Mr. Rishi? Murali? Yeah. Call to that Monish. Yeah. Second one. So what is the second type of acceleration? Is it completed? Then only I'll proceed. Is it over?
Yes.
Perfectly you make it. Then
Yes, sir.
Second one is called as, what is the type of acceleration it is? It is the tangential acceleration. Again, go back to the class 9th and remember. Do you all remember always? You can see at every point, you can notice it. If you draw a tangent, what do you mean by tangent to a circle? The line which is passing through the surface of a circle by touching only how many points?
1 point.
Touching 1 point. Class 9th orange color box, you might be remember that. Am I right, everyone? That is the reason I told you to revise 9th class. Remember, Rudreshwar, what is the importance now? So tangent.
Sir.
So tangent now. If you know this one, that's all, tangential acceleration. So we all knows that tangential acceleration means, we remember that magnitude also may changes. That is what? Change in speed is called as tangential acceleration. Understand? What is centripetal acceleration? Change in direction is called as centripetal acceleration. Now, change in speed means magnitude of velocity is also changing. That is what we used to call as tangential acceleration. Shall we start now, everyone? So see that at this point,
Yes, sir.
let me take at this point, I'm drawing a tangent and I'm taking another line, and at this point, I'm drawing a tangent, and I'm taking another one and I'm drawing a tangent again here. And everywhere I'm saying what? Magnitude is remains constant or magnitude is varies? Magnitude of a velocity. Everybody, magnitude of velocity is not constant. That is only, that acceleration only we used to call as, what is to call? Everybody, we used to call as tangential.
Tangential acceleration.
Okay, so let me consider at every point. See that by touching the 1 point I'm drawing, so you can notice it. Let me consider at this place, velocity is this, sorry, magnitude or speed, and at this point speed is v dash, and at this point speed is v double dash, and at this point speed is v triple dash. Clear? So that magnitude of the body is constant or varies? Everybody,
Varies.
that is only we can say. Keep it in mind, tangential acceleration means change in what? Not a change in velocity. What is that? Change in
Speed.
that is what we can say. Magnitude is changing. Understanding? Magnitude of velocity is changing. That is what we used to call as tangential acceleration. So V is always, value is keep on changes from one point to another plane. So here velocity is V, here velocity is V dash, here velocity is V double dash, here velocity is V triple dash. Ellave puriyama? Now, as we all knows that every circular motion object is said to be in what? Accelerated motion. Yes or no, guys? Everyone? So every circular path means body is said to be in accelerated motion. So let me consider, suppose if the velocity is increasing, then the acceleration is also acting in the same direction. So this is the tangential acceleration at this point. Now, here, for example, if I take, here also it is accelerating motion. So the tangential acceleration will be like this. So if you notice at every point, for example, let me choose a particular path alone and draw how the tangential will act. All of you check it. Suppose if this is the curved path, Rudreshwar can understand, Pradosh. So this is the curved path. For example, here if you notice it, I will draw a tangent. You all knows, correct guys, how to draw a tangent? Yes or no? All of
Yes,
you?
Yes, sir.
For example, velocity of the body or speed of the body is like this acting. Now, you remember, tangential acceleration will act like this. And we all knows that centripetal acceleration act towards to the what? At every point. Centripetal acceleration act always towards to the center or along the what? Along the
Radius.
radius. Okay. So now, so that is only you imagine. So at a particular point, velocity, tangential acceleration is acting like this direction, and centripetal acceleration is acting towards the center. So by this time you might be guess. Always there. What is that? What is the angle between them?
Perpendicular. 90 degrees.
Perpendicular. How much the perpendicular means? Everybody. That is 90 degrees. Clear, everybody? Understood or not? All of you. So tangential acceleration means, what is that? Change in magnitude. Please remember that tangential acceleration means what, guys? Change in
Magnitude
magnitude.
of
Okay. So now, if I draw, and what is the angle between them? Everybody, tangential acceleration and centripetal acceleration. Always they'll be acting perpendicular to each other. Clear? So now, the formula for tangential acceleration is equals to, again, same thing. Understanding? Change in velocity. Change in velocity or change in speed? Everyone. Change in velocity or change in speed? Just now I told. Velocity or change in speed? Magnitude, Udreshwa. So if I write, yeah, now velocity, Laksha, speed. If I say change in velocity, keep it in mind, I will write V. Like that, I'll write. If I say change in speed, speed means what? Magnitude of velocity. So magnitude always we have to put in where? Between the mod. Do you all understand, everybody? Yes? Yeah,
Yes,
that
sir.
is what you have to remember. So tangential acceleration means it is change in velocity or change in speed?
Speed.
Change in speed. That is why this is a perfect formula. For example, if I write like this is wrong. Why it is wrong? Anybody can tell? Because
Velocity.
this we indicate velocity. Okay, because velocity you cannot consider here, because velocity changes by what? Velocity changes by direction. Yes or no? Direction also it can
Yes, sir.
changes, magnitude also can changes. But if it is changing by magnitude, it is definitely a what it is actually. It is the
Change in speed.
change in speed. That is what you should understand. Everybody clear? Manya?
Yes, sir.
So what is the perfect formula for tangential acceleration? Everybody? Tangential acceleration AT is equals to differentiation of mod V. Mod V means what? Speed or velocity?
Speed.
That is the perfect formula. Please remember that. Okay. So now, if you observe very carefully, let me ask the question. Till here, complete it fast. 1 minute time. Make it quick. Any doubt, ask me. Completed? Yeah, do it. Slowly do it. Learn and do, no issues and all. We will learn. We have as much time. Definitely will do well. 100% I can believe. Only you have to work hard. Is it completed? That's all you tell me. If it is completed, we'll proceed. Shall we proceed?
Yes, sir.
Yes, sir.
Okay. Now, let us see. If you observe, if I say constant speed is constant. Can you tell me what is the tangential acceleration and what is the centripetal acceleration? If the speed of a body remains constant in a circular track, as I already mentioned you, I already given you the statement. Somebody cannot be zero at all. If the body is said to be in circular motion, always some acceleration is acting. What is that acceleration? Yes, please. What is the acceleration?
Centripetal acceleration.
Keep in mind, if the body is in circular motion, means the always one acceleration is already existed. What is that acceleration, everybody?
Centripetal.
Centripetal acceleration. Now, I am saying constant speed means what? Magnitude of velocities remains constant. That is the meaning of it. So magnitude of velocities remains constant. So that you tell me, what about the tangential acceleration? That is what I want it. Well, speed is not changing. Speed remains constant. So means in the sense of tangential acceleration is what?
Zero.
So keep it in mind. If the speed of a body remains constant in a circular path, tangential acceleration is equals to what? Everybody? If the speed is constant, tangential acceleration is equals to 0. But what about the circular? What about the centripetal acceleration? Still the centripetal acceleration is existed. What is the formula? Centripetal acceleration equals to two formulas you learn. Both is very important. What is that?
R1.
V square by R is equals to R omega square. So please learn. So
Omega.
from this you can understand one thing. Centripetal acceleration will never be zero, but tangential acceleration will be zero at what point? Yes, please.
Velocity.
When velocity speed is remains
Constant.
constant. That is what you have to remember. Yeah. Now, as I drawn here, what is the angle between tangential acceleration and centripetal acceleration? Everybody? Yes, please. What is the tangential and centripetal acceleration? All of you. 90 degrees. Understanding? So now if you notice it here, all of you observe very carefully. Always if you take in a circular path at any point, if the magnitude of speed is changing, so it is always the tangential acceleration act parallel to the motion and centripetal acceleration act always towards to the center, so that it will act how, guys? We all know center. Even physics you might be studied, I used to taught any line passing through the center of curvature or optical center. Do you remember, everybody? What is happening?
Yes.
Physics? Yes. That everything, what is the angle? Angle between the tangent at that, everywhere, at every point. This is the tangent and circular path. What is the angle between them? Everywhere. Yes, please.
90 degrees.
90 degrees. Do you all remember that? 10th class also we studied that. For light, the ray of light passes through the optical center, always goes in a straight line. Remember, Udreshwa? So that is what it is. So always tangential acceleration act parallel and centripetal acceleration acting how? Normal to the surface. Normal only we used to call another word. What is that called as? What we used to call Ra?
Perpendicular.
Perpendicular. Normal or perpendicular to the surface. That is what you have to remember that. Okay. So always tangential acceleration is parallel and now centripetal acceleration is perpendicular. And what is the angle between them? Always
90 degrees.
90 degrees. That is what you have to remember. That is what you have to remember. Okay, guys. Okay. Okay. So if there is no change, who is that? If there is no change in speed, so only one acceleration is existed. What is that acceleration, everyone?
Centripetal acceleration.
Yeah, centripetal acceleration. If there is no change in speed, then who will be zero? Everyone? Yes.
Tangential acceleration.
Tangential acceleration is zero. Please write that. If the body is moving with a constant speed, if the body is moving with a constant speed, in which path? Circular path. Write that. If the body is moving with a constant speed in a circular path, mod V is equals to constant. Mod V is equals to constant. So mod V is equals to constant means tangential acceleration is what? Everybody? Zero. Because no change in what? No change in speed. What is the tangential acceleration formula? D. Understand? D mod V divided by D. Okay? So that is fine. But who is always existed? Every time if the body is in circular motion, some acceleration is already existed. What is that acceleration? Centripetal acceleration. Both the formulas you should learn. V square by R or R omega square. Okay. So this is what about the two types of acceleration. One is centripetal acceleration and second one is tangential acceleration. Now, so rain problems and all, do you all remember rain problems? Everybody? Rain and umbrella problems and all. So now, for example, I'm saying, if the rain is, the man is moving like this and the rain is falling like this, some example you can see. Then what about the resultant force? Where the resultant force will act? Yes, please, like this. This is what we used to call as net force or resultant force. Do you remember, everybody? X-axis and Y-axis, the net force, like that. Same way, we are going to study now net acceleration, third type of force, acceleration, which we used to call as what acceleration it is? Net acceleration. NET. Okay. So let us see that. What do you mean by net acceleration means? Remember, no speed, only you should speak about velocity. Total change in velocity. Total change in velocity is to called as what? Everybody? Total change in velocity is to called as what? All of you. Net acceleration. So, okay. So net is equals to dv by dt. Do you remember tangential acceleration and net acceleration formula difference? What is that? Can you tell me? Yes, please.
Their speed here velocity.
So that is mod v, but here change in velocity. Understand, Mr. Dreswar? So that what will happen? As we all knows that it is a vector quantity and velocity is also a vector quantity. So change in velocity. So wherever you will get a change. So what is the symbol we have to use it? Everybody. We have to use it what? Mod. Understanding? So this is the formula for change in velocity. So change in that is what net acceleration is equals to. This is the first formula. Of course, we are having that. So velocity can be changed in a two directions. What is that, guys? Change in velocity in the two ways we can change it. How it is? Change in velocity can be happened by two ways. What is that? All of you.
Changing magnitude and
By
direction.
changing magnitude or by changing the direction. But here, but that is what it is. So change in velocity, maybe because of magnitude or maybe direction. So remember, only direction, net centripetal acceleration. Only speed, that is what magnitude we used to call as what we used to call tangential acceleration. Now, both magnitude plus direction we used to call as what? Everybody.
Net
Okay, so let us see how our net acceleration will act. So we discuss now. So again, I will take a circular path. All of you observe very carefully. Circular path I am observing now. I know that at a particular point I am choosing it. Let me choose. This is my point now. Now tell me, at this point, centripetal acceleration is acting towards the what? You have to speak. Centripetal acceleration acting towards the
center.
center.
Towards to the center.
Tangential acceleration acting. Tangential acceleration is acting for a tangent. That is what along the particular point. Yes or no? Everybody clear? So
Sir.
this is what tangential acceleration. Let me take the body is moving with some velocity. Now, can you guess and tell me? So you can see this is plus y and this is minus y. Just casually we will imagine that. So this is plus y and this is minus x. So now you tell me in what direction the resultant force will act? North, east or west? Northwest. That is what the resultant force. Am I right or wrong, Pradosh? This is the resultant force. That is what net acceleration. Okay, the acceleration which is acting towards to the center, we used to call it as centripetal acceleration, and away from that we can see tangent. We used to call it as tangential acceleration. So that net acceleration will act between them. Am I right, everyone? Yes, please.
Yes, sir.
That is what. Now, what is the angle between them? A and centripetal acceleration and the tangential acceleration? 90 degrees. And between them, the resultant force is acting. That is what resultant acceleration. That is only we used to call as what? Net acceleration. Clear, everyone? That is what. Now, so we all knows that net acceleration formula. We already studied that. Root over mod v something. Tell me that is only.
Mod dv by dt.
Yes, root over, we know two sides ra AC and this one we knows that. So what is the formula? We have been found it. AC square plus A square plus B square plus 2AB cos theta. Remember da?
Yes, sir.
That is what. So AC square plus AT square plus 2AC AT and cos theta. So what is the cos theta value? How much? What is the cos theta value? Yes.
0.
90 ra? 80. How much? Angle how much, Rudresha? 90 correct. That is what it is. So
cos 90.
yeah, cos 90 is 0. So that whole term will be removed. Net acceleration, what is the formula? Root over AC square plus AT square. Okay. So this is the formula for net acceleration. So please remember that. Okay, everyone, clear?
Yes, sir.
Yeah, great. Net acceleration formula. What is the net acceleration formula? Root over root over square of centripetal acceleration plus tangential acceleration. Okay, so that is what you have to remember, that always net acceleration act between what? Between centripetal acceleration and
Tangential.
acceleration. That is what is called as resultant acceleration, or we can say net acceleration. Clear? Now, so we all knows that we already solved plenty of sums. For example, that resultant force is acting with 30 degrees to the x-axis or y-axis. We all remember that. So then this is like boat and river problem. Remember, brothers, boat and river problem. Then
Yes,
x-axis, for example, it is reacting with a theta degrees with some x meter per second. Then x-axis, what will come here? Theta cos x, and here what will come? Theta
Sin X.
sin x. Clear? So that is what. Same way, let us find in x-axis what is the resultant force direction, resultant acceleration, and what is the y-axis, what is the resultant acceleration. We have to find it for the same thing. So we all knows that resultant tangential acceleration is always acting how? Perpendicularly to the centripetal acceleration. Am I right, everybody?
Yes, sir.
Clear? Now, what is the angle between them always? What is the angle between them? What is the angle between them? 90 degrees. That is what net acceleration will say. Now, let me assume this angle, what is to consider? Let me consider this is alpha. Sorry, this is alpha. And automatically we know that this angle will become what?
Beta.
Beta. Okay. Now, use the same thing, parallel shift. So first let us find alpha now. So tan alpha means AC will come here, parallel shift. So this is AC means here also AC. So that is a triangle. So what is a parallel shift now? You can write